For more information, please visit SGMAK Associates website.
Hi, purpose of this presentation is to use a simple problem, a warranty problem that you can all relate to, and explain some basic statistical concepts like concepts of random variable, probability density function, cumulative distribution function, how to estimate probability of an event, and how to use that probability to solve a real-world problem. The problem statement is given in the next slide. Warranty problem is all you can relate to when a manufacturer markets a product. Normally, a warranty is associated with the product. It's a differentiator. You have to give warranty if your competitor gives a warranty, which is typical, and warranty could be a differentiator. You all know about warranty for a car. It's 36,000 miles, or some car maybe 100,000 miles on certain items, a lower mileage, bumper to bumper warranty, and those sort of things. So we have taken an example which is given in the next slide about a warranty. An item, electronic item, warranty is of 1 year. If it fails within 1 year, it has to be replaced by a new item free of cost. Or you want to find out what is the impact of warranty on profit per unit. So the random variable of interest is the service life of the product. A free replacement is available to the customer if the product fails during the first year of service, which I just said that. The service life of the product has uncertainty associated with it. We don't know how long, after what period of time the product will fail, and it will not fail at a deterministic fashion. Not that it will fail every 1 year. It will have a variation associated with it, uncertainty associated with it, and uncertainty is best modeled using statistical distribution. So in this case, the service life of the product will treat it as a continuous random variable. It has randomness associated with it. It's continuous in nature because you are measuring time, how long it takes for the next failure to take place. In our case, the first failure. The example of a discrete random variable, this is a continuous random variable. If you think about a discrete random variable, the example is the number of defective parts that you make over a certain time period, and I have taken 8 hours arbitrarily. So you got a process manufacturing a product. You have stabilized the process. It's stable now. It's giving you some output. It will typically generate some defective parts, even if it's very low. And what you're looking at here is the number of defective parts generated over 8-hour time period. So that number will be, if I focus on different 8-hour run, the numbers will be different because of uncertainty associated with the process output. And you are looking at a random variable number of defective parts on 8-hour period, which is discrete in nature. So the current problem is dealing with a continuous random variable. And a manufacturer of an electronic gadget offers 1-year warranty. We talked about it before. If the gadget fails for any reason within the warranty period, it must be replaced. The time to failure is well modeled by an exponential distribution. Whenever you have uncertainty associated with a variable, with a random variable, we call it random when you have uncertainty associated with it, it's typically modeled by a statistical distribution. And we are now only looking at univariate distribution. Exponential distribution is used, has lots of use to model service life. It models a random variable with non-negative value. The manufacturing cost of the unit is 130 and you are selling at a price of 130, so your profit earned is $30 per unit. Manufacturing cost is $100 per unit and you are selling at $130 per unit, so you're getting a profit of $30 per unit. Question is, what is the effect of warranty on profit earned per unit? Idea is, if you didn't have a warranty issue, if you didn't offer warranty, then you're simply getting $30 unit, $30 profit per unit that you can sell. But when you offer warranty, a percentage of what you have sold will fail during first year and they have to be replaced free of cost, and that will lower the profit per unit, and that's what we want to find out. We'll have a profit per unit which will be lower than $30 per unit due to warranty. So moving on, to solve the problem, we need to estimate the percentage of products that are likely to fail within the warranty period of 1 year. If you change it to warranty period of 2 years, then you want to find out what is the probability of failure during the warranty period. The most of the real-world application of probability lead to estimation of probability of one or more of the following events. You always find probability of an event. Probability the random variable takes value less equal an arbitrary value k. Probability random variable takes value greater equal k. And most common is probability the random variable takes a value between two bounds a and b. So those are the events associated with a random variable, and we estimate the probability when you know by manipulating the statistical distribution. Here x represents the random variable of interest, and you need to estimate probability x less equal 1 because we are measuring time in years here. The problem statement states that the service life is modeled by exponential distribution with a mean of 4 years. So average failure, the gadget fails is 4 years. And the service life is modeled by exponential distribution. A random variable is modeled by appropriate statistical distribution identified through fitting distribution to historical data. Though I have just said here that it follows exponential distribution, in real world, you just can't arbitrarily slap a distribution on a random variable. You collect historical data, and there's a formal method of identifying a distribution that best fit the data. Okay, that's not part of the discussion now. Two relevant concepts that are associated with the statistical distribution are probability density function. A random variable will be modeled by a statistical distribution. Statistical distribution have a probability density function for a continuous distribution, or probability mass function for a discrete random variable, and the cumulative distribution function, CDF. One is probability density function represented by PDF, and the cumulative distribution function represented by CDF. The CDF is derived from the PDF and is used to estimate the probability of an event. So importance of CDF is it is used to find the probability of an event, and we use that probability to do other things to solve the problem. Each distribution has unique PDF as well as unique CDF. The PDF of the exponential distribution is expressed as fx, the density function, equals lambda times e raised to the power minus lambda x. So as you can see, x is the random variable, which is the service life here. There's only one parameter of the distribution, which is lambda, and lambda equals 1 over the mean. So in our problem, average life is 4 years, so lambda is 1 over 4, which is 0.25. So how do you solve the problem? The CDF plays a very important role in estimating the probability of an event. By definition, for any probability distribution, the CDF evaluated at x equal k is typically represented by f of k. It returns the probability the random variable takes value less equal k. For a continuous random variable, the PDF represents the ordinate of the density function evaluated at x equal k. So fx, once you have if I give you the density function and if you plug a specific value of x, the f of x, what you will get is not a probability measure, but is the y value of the density function at that value of x. From the problem statement, the average life of the product is 4 years. Therefore, the parameter lambda is 1 over 4, 0.25. We talked about it. So what is the probability of failure during the warranty period? So probability that x less equal 1 is returned by f of 1, CDFF, and x equal 1. And that value is 0.222 or 22.2%. So there's a 22.2% chance of failure of the product within the warranty period. We simply took the CDF and plugged the specific value of x to find this probability. So now the probability of failure of the, though it's not related, but I've just calculated, the probability of failure of the product within the average life is 63.2%. So if it follows exponential distribution, whatever the average life is, the probability that it will fail within the average life is 63.2%. The profit per unit in this case is a random variable, because if the product doesn't fail, you're generating a profit of $30 per unit. But if it fails, then you get revenue $130, but you got to give away 2 products, each cost you $100. First one that you sold, original one, then you got to give a free replacement. So really your profit, you're making a loss in this case, 130 minus 200, minus $70, $70 of loss for each item that fails. And what you're doing here, we are multiplying the probability profit measure with the corresponding probability. So 30 multiplied by probability x greater than 1 was the chance that gadget will survive past 1 year. And in that case, we get $30 plus, and then plus minus 70 times probability x less equal 1. So here's an important concept here, and which is the term that I've used, expected profit. Expected profit is a long-term average profit. Profit in this case can take only 2 values, $30 with a probability of 0.778, probability px greater than 1, and profit is minus $70 with a probability of 0.222. So what we do, the expected value does a weighted average. We multiply probability with profit with corresponding probability, and you get a weighted average weighted by corresponding probabilities, and that comes out to be $7.80. You're losing quite a bit when a product fails, because you're losing $70 per unit that fails. You're only making $30 profit if it passes warranty period, and that's because of the data. So loss of profit due to warranty. If I didn't offer warranty, I would have made a profit of $30. But with a one year warranty, I'm making a profit of $7.80 only. So how much is the loss? Loss is $22.20. So impact of 1 year warranty on profit per unit, given the data, given the failure rate, is $22.20. You can also find out the impact of 2 years warranty. All that you have to find out, what's the probability of failure within 2 years. Okay, it will have a higher probability of failure, and then we'll be losing a lot more money. but you got the mechanics. So this example, to close, this example this is an example of application of probability in real world examples, real world problems, because you all can relate to warranty. This example introduced the concept of random variable, a variable that is associated with uncertainty like service life, is a continuous random variable. It talks about the density function. It talks about the cumulative distribution function. We haven't talked about the conversion here, because conversion from PDF to CDF for continuous is come through integration, and for a discrete is come through summation. I think I have posted another slide, another clip where I talked about PDF and CDF. So it introduces a random variable PDF and CDF of a statistical distribution, how you use CDF to estimate the probability of an event, and an important concept of expected value of a random variable. Expected value, the simple term is long-term average. And what happens is, all that we do here, we look at the different values the random variable can take, and we estimate the corresponding probability for each value. Then we do a weighted average, multiplying the value of the random variable with corresponding probability, we get a weighted average. And that's how you represent. So expected value is the long-term average weighted by the corresponding probabilities. It plays a very important role. So hopefully this example will be of use to you. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.